So this is the Unit 4A review session for electrostatics for college prep physics, and we have our test on Friday, so we're just going to get some things going. I'm going to walk through a couple things, get through the review, and hopefully this is useful to you. If you're watching this on the live stream, feel free to ask me questions either via the chat or using the Remind app on the phone. If you're watching this on the YouTube, well, hopefully you find this useful. Like I said, I'm just going to walk through the review, show a couple main points. You're going to see me looking over to the right, my left every once in a while, just to see if anybody's asking questions on the chat. And I'm not seeing anything right this second. Just a couple things. On the OneNote, you're going to see, I haven't put it up there yet, but I will momentarily as soon as I'm done with this. Just suggestions for the note card, because you could use a note card. I'm going to have some available tomorrow. And right now on the screen, you can see I have some big suggestions, and these are the minimum, bare minimum that I would have. And actually all of these that are written right now have to do with the second part of the unit, the Coulomb's law stuff. So I have, of course, the equation. And I have here a little arrow pointing to that squared, because a lot of times, I mean, it's probably happened to you once or twice where you kind of forget to square it. And so that's the big one. Down here, I have what K is in case, because you're going to forget. You don't want to have to remember that. So I have it written two ways. I have it written in the just standard regular scientific notation with all the units and everything. And then I have it as like the calculator version of it. So this is how I would type it into the calculator when, actually I might even just put parentheses around it, because you're going to want to have parentheses around just about everything in the calculator. One other thing is the distance equation. So it's basically, if you take this equation and you rearrange it to solve for distance, this is what it's going to be. And as you saw in the thing today outside the classroom, it's a fair game question, so just be ready. It's the same variables, just flipped around and rearranged. So that's possible to have that on there. And have a little arrow pointing to the square root, because a lot of trouble today I saw was from when you forgot to take the square root. Another actual trouble was forgetting to put this K in the equation, but I'm not sure how to put that in there without being, make a mark without being too intrusive. I suppose I could just like underline it in a different color, but you do whatever works for you. All right. I also had the relationship between charge and the electric force felt. So this is a direct relationship. I'm just going to put the word direct relationship. Okay. And that is basically whatever happens to the charge, that's what happens to the force. In other words, if you've got two charged objects, we'll just put like a positive and a negative. If you like increase the amount of charge, like if you make this double the charge, well then this is gonna the force between them, the Fe like between them that they're feeling pushing or pulling, actually pulling in this case, is gonna double. So if you double the amount of charge, you're gonna double the electric force between these. All right, so that's what's going on here. If you cut it in half, you're going to feel half the force. The other one is for distance, and so you have to pay attention to what the question's asking. If you, in this case, double the distance, you have 1/4 the amount of force. It's the and then triple the distance, you have 1/9 the force, and so on. And then the opposite is true, or the inverse is true, where if you have half the distance, you're going to have 4 times the force. So if the two charges come closer and the distance is half of what it was, they're going to feel 4 times the force. If the distance is 1/3 of what it was, they're going to feel 9 times the force, and so on. And this is the inverse square relationship. Okay, and that's just the name of it because you have to inverse it. In other words, you have to, like, for example, for double the distance, you have to flip it over. It becomes 1/2. And you square it, so that half becomes 1/4. So again, if you just have that on there, it's going to help you to remember the relationship between those. That's part of it. And you have the whole note card. So you can also put like example problems or problem, okay? Or anything else you like to put on there. One thing that's not on there is the like protons, neutrons, electrons. In other words, the atom stuff. I would suggest maybe adding that on there if you're not sure. Protons are positive, neutrons are neutral, and electrons are negative. That's all stuff that's fair game for the card. So feel free to go back and pause this at any time and write that stuff down. But also look on the OneNote, because on the OneNote I'm going to have a picture of my card that I wrote. It's only one-sided though, so if you could squeeze it all on one side, you have the whole backside to add whatever you like. You can write whatever you want, okay? That's kind of questions we ask are going to be, you have to be able to use the information. All right. So, not seeing any questions yet, that's fine. So looking at the review. So here's the review guide. I'm just going to scooch this out of the way. All right. So, standard notation. Standard notation, you literally just, I mean, honestly, you could just put this in your calculator and it would be 6.5, and I'm going to use e to the 6th. So you get that, and basically what's happening is you move the decimal point over 6 spaces. It's literally 6 times a 1 with 6 zeros after it. So you move that over 6 times and you get 65. How many zeros? So I'm looking at my calculator. It's a lot of zeros. 1, 2, 3, 4, 5 zeros. 4 or 5. Okay, and just to show you what I was talking about, so I move the decimal point over 1, 2, 3, 4, 5, and 6. So that's where the decimal point would be. You can do the same thing for number 2. So it's just going to be 2 and 8. So there's 1, 2, 3. I need to go to 5. So 1, 2, 3, 4, and 5. So that would be my answer, and I could check that with the calculator. I'm guessing I'll be correct, but probably should do it really quick just to be on the safe side. So 2.8 times 10 to the 5th, and yeah, so I got 4 zeros, and that's how many I wrote. Now, you're not going to get asked questions about scientific notation like that necessarily on the test, but just be prepared. I mean, obviously you deal with this stuff all the time in the Coulomb's law equations. Scientific notation, again, the same idea. I don't want to spend a lot of time on this, but it's just the reverse of that. So this is going to be, you want to try to stick to, in our case, 2 digits. So the 2 important digits, the 2 first digits, 9 and a 6, put a little decimal point in between those. And since I had to move the decimal point over 1, 2, 3, 4, this will be times 10 to the 4th. All right, that's all there is to it. And the same thing here. Now this is a lot of digits, so we're going to skip down to we only want 2, 8.2 times 10 to the, now how many decimal points do we have to move it over? How many spots? 1, 2, 3, 4, 5, 6, 7. So this will be -7. And you can verify that in your calculator, check it out, but that's basically how it goes. All right. So I went through that pretty quick. So if you need to hear it again, rewind it, or ask me in class or whatever, remind. Multiply the following numbers and use it in scientific notation. There's 2 main ways to do this. Obviously, the one way is just use your calculator. So I'm going to do that for this first one. I'm going to use parentheses. I'm going to do 1.2 and this e, the capital E. It's like, you don't use the lowercase e, to the 4th, and then 2.0. Where'd that e go? E to the 4th again. See? And I get that big giant number. So that's one of the downsides, and I'm using a graphing calculator, so you might get that sometimes. But the other way to do it is just multiply the 2 numbers, the 2 main numbers together, 2 base numbers together. So in this case, 1.2 times 2 is going to give me 2.4 times 10. And then, so I just multiplied those 2 numbers together, 1.2 and 2.0. And then I add the exponents together. So this will be to the 8th. And I'm guessing if I put 2.4 times 10 to the 8th yeah, I get the same exact answer as I got before. It's the same thing. So that's how you do it. And again, you know, you're not going to have to do this by hand. You could use a calculator tomorrow. So either way is fine. So for the next one, I'll just do it really quick in the calculator, 3.2. Because again, this test is not about scientific notation. I'm not going to ask you questions like these, like out of context, like they don't mean anything by themselves. The -5. You're going to have to use this stuff while, for example, doing the Coulomb's law questions. So what is that, -2? And assuming I punched it in there correctly, 3.2 and -5. Okay. So my answer, I mean, see, it's like already done for us, times 10 to the -7th. All right. Dividing, same idea. All right. It's been 15 minutes. All right. I'm just going to like assume you know how to do the division. It's the same thing as, I'm going to do 1, I guess. So it's the same thing. Put it in parentheses, 0.0 times 10 to the 5th divided by, and 2.0 times 10 to the 4th. Okay, so that's my answer. That's just how it goes. Put it in the calculator just like that. Use parentheses. Okay, practice that stuff if necessary. When it comes to drawing an atom, this is the kind of stuff, like I said, that you're going to want in your notes, or maybe even on your note card. So a proton, I'm just going to put a little note here, is Crunchyroll, is positive, neutrons are neutral, and electrons are negative. Okay, so just remember that. And the positives and the negatives, the protons and electrons, need to equal each other if we're going to have a neutral atom. And so the only thing I do is I'm just going to put, I guess I'll put like 3 protons, 1, 2 neutrons in the middle, and then on the outside I'm going to have 1, 2, 3, and then again, it doesn't, I'm not looking, this isn't chemistry. Later on in chemistry you're going to learn like the proper atomic model, but basically what's going to happen is these are stuck in the middle. Protons and neutrons are stuck in the middle. And I'm just going to put a little note, stuck in the middle, the nucleus. You do know the word nucleus, but I'm just going to put both nucleus. Okay, and so that's sort of the fundamental, like why electricity involves these electrons, because the electrons can move, the other things cannot. All right, and that answers number 10, actually. Electrons can easily, in a conductor, they can move around in an insulator, and they cannot move around. They can move around in a conductor, they cannot move around in an insulator. That's great handwriting, Mr. Jern. But they can move around. Listen to my voice. So, what 2 types of objects attract each other? This is another thing that you can put in your notes card if you'd like to. So attract, let's see, attract. Let's just be, I guess we'll do all the possibilities. A positive and a negative, a positive and a neutral, and a negative and a neutral. Those 3 will attract. For repel, well, so opposites attract. So for repel, a positive and a negative will repel. Those are the charges. Nothing. Well, neutral and neutral will do nothing because they're neutral, they're not charged. So that's our combinations. Those are 6 possibilities. And I think we have them all. All right. Moving along then. If an object gains electrons, it has a negative charge. Hopefully you got that one. So to become positively charged, for number 13, it has to lose electrons. And the reason is because the protons are stuck in the middle. They can't move. So you're not going to gain protons to become positively charged. They won't. So what happens is you lose electrons, and now you've lost that balance. So now you have fewer electrons, and so now you have more protons. And so since you lost some electrons and you have more protons, it's going to be positively charged. All right. The balloon question. You might not get asked this directly, but you need to know how to do this because it might come up. So you might come up with a situation that's not balloons, but it might be similar. And you have to do just a little logic, okay? Just game the whole thing out. What are all the possibilities? So X is negatively charged. We know that because it says so. X is negatively charged. We want to know what Z is, but X and Z aren't touching each other. So we have to figure out what Y is first. Y is touching X, or interacting with X, because it might be repelling in other situations. We don't know if Y is positive, negative, or neutral. We had to figure it out. And then from there, we're going to figure out, is Z positive, negative, or neutral? And so because it's attracting, I'm just going to do this. Okay. It's attracting a negative and a positive. Will that attract? Yes, it will. Then I'm going to say, all right, will a negative attract a negative? It will not. It would repel. Will a negative attract a neutral? Yes, it will. So what that tells me is Y could be positive or neutral. So now I have to figure out for all the situations, it's the same thing. Now Y, we don't know Y is positive or neutral. It's one of the two. So what I need to do is go, all right, if Y is positive, could Z be positive? No, because it would be repelling if that was the case. If Y was positive, could Z be negative? Yes, it could, because they would attract. If Y was positive, could Z be neutral? Yes, it could, because it'll attract. Okay, so that's one possibility. Then I need to try out another possibility. What if Y is neutral? Well, if Y is neutral, would it be attracted by a positive? Yes, it could. If Y is neutral, could it be attracted by a negative? Yes, it could. Y is neutral? No, couldn't be attracted by another neutral. So here's my possibilities, these and these. So it looks like Z could be any of them. So it could be any of them. And we don't know. Okay, it works out either way. So we figured out every single situation, and any possibility is there. It could be anything. All right? Backside. So part 2 of the unit. The relationship between distance and the force between the two charges. We talked about that, and so that's going to go into this right here, this little chart, these two charts right here. So if you can remember that, or you get that written down, this shouldn't be a piece of cake. So looking at that, the relationship between distance and the force between two charges is the inverse square. I'm not going to ask you that name, but make sure you know what it does, what it means. So the amount of charge and the force between two objects. So this one was distance, and this one is amount of charge. And like I said, oops, that's not it. It's a direct relationship. Okay, so whatever happens to one happens to the other. So now if the distance between two charges is increased by 3, how much does the electrical force change? So here we're talking about distance. And if I look at my little chart, or I just remember inverse square, then it's going to be 1/9 the strength. So whatever the force was, take 1/9 of that, multiply it by 1/9. So it's going to be 1/9. If the distance between two charges is quadrupled, or 4 times, what's going to happen to the electrical force? Well, 4, so 1/4 squared is going to be 1/16. So it's going to be 1/16 the electrical force. All right. Now, if two charged objects are close together and one of the charge is doubled, what happens to the force? Well, double just means doubled if it's a charge. So you're making the charge stronger. You're not changing the distance. You're just increasing the strength of the charge, basically. All right. So there you go. That's that. Inverse square, direct to me. So just again, I'm going to bring you back to this thing. Remember this. Look at it. Make sure you understand these two relationships. This one is for charge. Whatever happens to the charge happens to the force. The direct relationship. This one on the right is for distance. It's the inverse square. See the pattern, understand the pattern, get it down. All right, whatever happens to distance, this is what has to happen to the force. Okay, so it just gets weaker or stronger exponentially. Change the distance. All right, take a look at. So I'm going to skip around on these last four. I'm going to do 20, and then I'm going to do 22, and then I'll come back and do the other two. So we want to know the force between a -3 charge and a -10 charge. If they are 5 meters apart, do they repel? So I'm going to, of course, I mean, in this case, I could underline these things. I could kind of mark these down, and I think you'll be able to do the same thing here. You might just want to say this is a charge, it's a charge, and this is a distance. Okay, it's always, if you can, it's always a good idea to mark these down, what they are. That's part of physics, is recognizing what variables you're dealing with. All right, so it wants to know what is the force. So that means my electrical force is the question mark. What is it? I know that C is a charge, a Q, it's a Coulomb. So my first charge is going to be -3 coulombs. My second charge, and it doesn't matter the order, is going to be -10 coulombs. Pause this, by the way, if I'm going too fast. You just pause it, you could finish writing. Okay, honestly, you should have done this already, tried it, and then be watching this, but, you know, whatever works for you. So the distance is 5 meters. So I need to find the force, then I could figure out if they repel or not. So I'm going to use the equation. I'm going to check my little note card that I made because I don't have this memorized necessarily. And I want to find the force. So I'm going to do K times Q1 times Q2 divided by the distance squared. Then I'm going to write this down because I know that if I just try to plug things in calculators, I'm going to forget something. And then if I get a wrong answer, I don't know what I'm going to, I won't know I won't have known what I did wrong. So I'm going to write this down, FE, and I'll just, you know what, I'm going to write it down as if I'm going to put it in the calculator. I'm going to, just for now, forget the units because we've dealt with units and it all works out. So I'm going to write 9E9 times, the first charge is -3 coulombs, but we're just kind of how we're going to do it in the calculator, times -10 coulombs. Okay, divide that by the distance, which is 5 meters. We're going to square that. Okay, don't forget that square at the end. You have no idea how many times students ask me, how come I got the wrong answer? And I say, well, you forgot the square. And it's very common. So I'm going to do that almost exactly like I wrote it down. 99, parenthesis, and -3 times -10, and divided by 5. So I could put 25, but I'm just going to put it in there just like I wrote it down. And assuming I did that correctly, I'm going to just double check to make sure it looks good. I should have 3 on top and 1 on the bottom. So my answer is 1 point, you could write 0.08, but I'm going to put it down to, I'm just going to round it, times 10 to the 10th newtons. And it's a positive number. Okay. The question is, do they repel? And there's 2 ways you can look at it. One is they're both negative, -3, -10. What do 2 negatives do? What do 2 like charges do? They repel. So yes, they repel. The other way to look at it is a positive force, which means they're pushing on each other. They're pushing each other away. They repel. All right. Now, where'd that n come from? I'll do the next one with the units, and then you can see where the units come from. We've already talked about it a lot, but I wanted to show you calculator version. This next one I will, I'll do calculator version as well, just so again you can see it. So I'm going to skip to 22. That way, if you want to call this quits, you can afterwards. But this one is asking how far apart are they? Okay, in other words, it's asking for the distance. So D is going to be my question mark. It gives me a charge of this, so that is a Q, probably Q1, and the other charge is going to be Q2. they experience a force, much force on the pencil, of that much. So this is going to be my FE. So I've marked it down. I just want to write it down now because it's not really organized. It's just sort of picked out. All right. So Q1 is going to be 4.2 times 10 to the negative 2 coulombs. Q2 will be 2.7 times 10 to the negative 3 coulombs. And my FE, my electrical force, which is given, and you have to pay attention. Oh, you have to pay attention because it says the force. Don't just go plugging numbers into that other equation because this isn't the time for it. You got to look out for what you're trying to find. Times 10 to the second newtons. Okay. So I've already done this. I'm not going to show you how to do it because that's algebra. We've talked about it many times. But now I need to rearrange this equation up here to solve for D. And since I have it written down on my note card, because I've already worked it out a few times, I've done this in practice, I know that the distance is the square root, don't forget the square root, of Q1 times Q2 times K divided by FE, not squared. Okay, don't just square things. Watch out for that. So like before, I'm going to just plug this in. Now where did I get this? Well, like I said, you worked it out and you got it from this equation up here. It just, this is the distance part of it when you're solving for distance. So distance is the square root of all this, 9, and I'm doing calculator version again, 99 times Q1, so 4.2 E, negative 2, running out of square root, times Q2, 2.7, times 10 to the negative 3, divided by the FE, 1.8 times 10 to the 2, not squared. Okay, so that's what it's going to look like. I'm going to put it into my calculator almost just like that. So let's get that line. You know what, I'm covering it. You're probably writing stuff down. Well, it's a video. Go back and pause it, and then you can write stuff down. All right. So now I'm going to do it all in one step. Be careful about breaking it. You can totally break it up, and you could do the top part, then multiply them all together, and then you could divide that by the bottom part, the force, and then you could take the square root and you could do all separate lines. That's fine. That's fine. It'll work out. But it's also more, it just increases the chance of you making a mistake. Then again, doing it this way might increase the chance of you making a mistake because I need to put an extra parenthesis there because I want to take the square root of all of the whole thing. I don't want to just take the square root of this first 9E9, okay? So double your parentheses here if you're going to do it all at once because I want 9 times 10 to the 9th. Oops. Nope, I was right. And multiply that by 4.2 times 10 to the negative 2. Okay, see how like we're multiplying it, but all that is included in that first parenthesis. And so multiply that by 4.2 times 2.7. I think I got this. No, I hit the wrong button there. I hit the wrong button again. There it is. Times 10 to the negative 3. All right. And then I'm going to take that, and it's still all in that first parenthesis, times 1.8 times 10 to the second. And I could end that first parenthesis, and you could just take a look and you can see it's all contained. So this parenthesis ends over here, and all that is going to be square rooted. I just hit something. Okay. So my answer is, it's a standard number, 75, we'll just call it 0.3 meters is going to be my answer. All right. So that's it. I'm going to do the last two, but if you want to stop it here, that's fine. It's been 30 minutes. And try the other ones yourself. Come back to it if you haven't yet. Honestly, like I said, you should have tried these first ones first on your own. So hopefully that helps you. But I'm going to go back and do 21 now. Okay. I'm not seeing any questions yet, so that's fine. Just watching. like I said, it's hard to type out questions. I'm just going to check my phone. All right, no questions on your mind. So looking at question 21, very similar to question, well, here, let's see what it's similar to. It wants to know what is the force. Okay, so it's asking for Fe. That means that's our question mark, and so we're going to get to use that first main equation. It says that's a charge, so that's going to be a Q, and this is a charge, so that's going to be a Q, and 2 meters apart is going to be our distance. Oh, do they repel? I forgot to answer that for question 22. Well, they're both positive, so they repel. Okay, so Fe is our question mark. Q1 is negative 1.8 times 10 to the negative 3 coulombs. Q2 is equal to 5.5 times 10 to the negative 4? Yeah. 4 coulombs, so I got the first charge, and then I got the second charge. Distance, I'm going to squeeze down under there, is 2 meters. So that's my stuff. That's my unknowns, my unknown and my knowns. And because I'm trying to find the force, I'm just going to use the regular equation, K times Q1 times Q2 divided by distance squared. All right. And excuse me, honestly, that equation will work no matter what you're solving for. You would just have to solve for the missing, you just have to solve for the variable. All right. This equation would work, for example, for question 22. You would just not have distance, so you would have to solve for it. You had to rearrange everything. So this equation is fine, and just this writing that down saves you some work. And to be fair, this equation would work just as well too. But anyway, probably easier if you just know which version of the equation to have handy. So K is 9 times 10 to the 9th Newton meters squared per Coulomb squared. And you can see I'm not writing the calculator version of it. And that's K, so don't forget K, by the way. Q1 is negative 1.8. The problem is I might run out of room. Times 10 to the negative 3 coulombs. And Q2 is 5.5 times 10 to the negative 4 coulombs. I don't think I'll run out of room. All that over 2 meters squared. Now, why did I do that? I just wanted to reiterate or show you again how these things cancel out. So I got coulombs multiplied by coulombs. Those are going to cancel out with this coulombs on the bottom down there, coulombs squared on the bottom. We have the meters, which are about to get squared, and that meter squared will cancel out with this meter squared. And that will leave us with the unit of force, newtons. All right, so I'm going to put that all into the calculator. So I'm going to cover up all this stuff. Let's clear that out. So I'm still going to put 9 times 10 to the 9th, 9e9, times negative 1.8 times 10 to the negative 3. Okay. 5.5 times 10 to the negative 4. Keep looking at my screen. Divided by, well, 2 squared. So I guess I could just put 4, but we'll be consistent. So make sure I did that right. It looks correct to me. It's 2 squared. All right, well, it's going to feel a lot of force. So it's going to feel negative 2,220, what is it called, 28 newtons. Because I'm running out of room on the paper. I'm just going to double check to make sure that I did this correctly. All right, times 5 times 4 divided by, so 99, and It looks good to me. I think, yeah. I guess so. Let me just try one more thing. Let's just divide it by 4. As soon as I'm going to do that. Oops. So here, you know what? Being all secretive here. I just reset this and something's not quite right. That's the old one. What the? Well, it's going back in time now. It's gone. Oh well, it's fine. I'm 99% sure I did that correctly. Anyway, it's a negative force, which means they're pulling together. We got a negative and a positive, so they don't repel, they attract each other. Because it's a negative force and you have a positive and a negative charge. All right, last one. Then I'm going to call this quits and we'll be under 45 minutes, I hope. So how far apart? How far apart is going to be D? We're trying to find distance. One has a charge of this, so that is going to be Q1. The other has a charge of this, that could be Q2. They experience a force, so that's kind of a big clue there that this is our Fe. And so we want to know how far apart they are. So how far apart they are? Well, distance is our unknown. We've got a Q1 of negative 2.6 times 10 to the negative 4th Coulomb. Q2 is equal to positive 6.7 times 10 to the negative 2 Coulomb. And the Fe, electrical force, is negative 1.8 times 10 to the negative 3 newtons. So once again, I'm trying to solve for distance. So I'm going to use that rearranged version of the equation. So Q1, Q2, don't forget K, and divide that by Fe. All right. So you know what? I'm going to do the non-calculator version again, and just to show you how the units cancel out. And I'm not going to write the square root until the end because, well, you'll see. So it's 9 times 10 to the 9th Newton meters squared per Coulomb squared times Q1, negative 2.6 times 10 to the negative 4th coulombs times 6.7 times 10 to the negative coulombs. All that divided by Fe, negative 1.8 times 10 to the negative 3 newtons, and square root all that. Don't forget the square root. Okay, like before, these coulombs squared will get canceled out by this coulomb and that coulomb being multiplied together. And the newtons in this case is going to get canceled out with the newtons on the bottom, leaving us with meters squared, which will get unsquared by the square root. So that's where that comes from. So distance, spit it out. So again, I'm going to do square root, and I'm going to have to add that extra parenthesis. So don't forget that extra parenthesis. 9 times 10 to the 9th divided by negative 2.6 times 10 to the negative 4 times 6.7 times 10 to the negative 2 divided by negative 1.8 times 10 to the negative 3. And I finished that all off, and I have an error. Let's see what it was. I put that instead of, okay, so let's just double check. So I put a division instead of a, I don't know why I put a division sign. All right. Well, with my error, I'm going to have to make sure I did this correctly. So 9 times 10 to the 9th, negative 2.6 times 10 to the negative 4th, that's correct. Parenthesis. 6.7 times 10 to the negative 2, okay. I'll divide that by this, 9 times 10 to the negative 3. And so we're good. So the distance is 9,332.7, we'll just call it meters. All right. So that's it. Go back and watch it if you have questions. I'm going to end just by putting this back up. And just remind you that there'll be more information on the OneNote. So that's all I have to say about that. I believe that's about it. So just make sure you study and do the practices and you will be fine. All right. So thanks for watching. Hopefully this was helpful, and good night and good luck.